So if we go back to the last lesson, we were dealing with exponential equations. And what I want to do is I want to start with solving this exponential equation, which is a bit of a tougher one. And I want to ask my group of students, where should I start? What strategy or technique do you think might be helpful for trying to solve this? Any ideas? This is a harder question that someone who wants to get above 50 to 60% will need to start answering. And so I want to know, what tools have you got in your toolkit? So Amakle, is your hand up? I'll unmute you. What do you think? Where would you start? Or does it feel a bit...
So don't you put the 105 into its prime factor?
You could put the 105 into prime factors. Would you say 3 times 35? But it's still a bit tricky. So
Yeah.
it is a tricky one, but Mtanda's got a good thing. What if we split the exponents? Okay, let's go with that. I like that. What are you guys noticing about? I'm noticing this. I think what we need to do is take out a common factor. And we'll leave the 105, but what do you think is going to go inside this bracket? Okay, Tanda, what do you think should go in the bracket? I'm going to unmute you.
3 squared should go in the bracket.
Yeah.
Plus 3 to the power 3 minus 1.
Oh, that was the tricky one, eh? So there's always a 1 there. And so that is the key thing. Okay, now I want you to try and take it from that point and see if you can get from there.
So basically we add the what you call the numbers inside the bracket.
Yeah. So if we do that, what are we going to get? I suppose 9 plus 27 minus 1. Yeah. And then what are we going to get? So that would be 35, I think, eh? Because 36 is 9 plus 27. So yeah, it's going to be times 35. And then what are we going to do after that?
I think we divide both sides by 35.
Yeah, so we're going to divide both sides by 35.
Yes.
And then we get that. And then okay, and actually that's fine because that's going to be 3. So what does x have to be?
X is equal to 1.
Perfect. Thank you very much, Simtanda. Yeah, so that was okay. So give me a face or like finger for like up if it was good, down if it was bad, face in the middle if it was in the middle. Okay, let's have a look at what people are saying in the chat. Okay, let's move on to this next one, which is a little bit tricky. At the end of the last lesson, we had another type of question. There was a special technique that I introduced, and I think it might be useful again here. So I'm going to zoom in a little bit so that the other one is not as much of a distraction. What was the technique we used to solve this exponential equation? This is really meaty. This is like a decent one. What technique at the end of the last lesson? Amakle, your hand is up, so I'll go to you. What do you think? Can you remember from the end of the last lesson, what special technique did we use? Okay, I'm going to suggest there was something called a substitution method. What did we have to substitute? Well, let me rewrite it first, and then you can tell me. I think I can rewrite this as that. Now, what do you think I need to substitute? What do you think I need to substitute? Welcome to Amy, and who's also joined us. The K method, yes. So we are going to say, let 5 to the x equal k. And now I want you to write out what you think the blue equation is going to be once I sub the k in. So I want you to write that down on a piece of paper. So write it down. And so we get, oh, what's going on? Okay, we're going to have k squared minus 30k plus 125 equals 0. Now, I want you to solve that for me using normal methods. What type of equation is that? What type of equation is that? It looks to me like a quadratic equation. So I think the factors that I'm going to use, yes, Amy. Now, what do you think are the factors I'm going to need to use? So if that's, I think 25 times 5 gives me that. And then this is going to be k minus 25, k minus 5 equals 0. And then if I know that, using the zero product property, different teachers call it different things, we get k is 25 or k is 5. Now, I'm not done. What do I need to do next? What do I need to do next to finish solving this rather juicy equation? Yeah, so we need to connect it back to the 5x, eh? So we're going to go 5 to the x is 25, or 5 to the x is 5. So what does my x need to be equal to? What does my x need to be equal to? I think 25 is 5 squared. So it has to be 2. Yes, Amy, absolutely. And Siamtanda, absolutely. And the other one is x is going to be equal to 1 because that's 5 to the 1. Okay, now that is like about as tricky as it gets. And so I want to see if we can do another one which is similar to that, but let's pause and take a screenshot if you need to of the method I use, because that was quite a decent one. Are there any questions before I move on? Or give me a thumbs up if I can move on. Okay. All right. Then we are going to move on to number 8. Now, number 8 may look tricky, but it's still the key thing with these type of exponential equations is, do you notice that the one power is double the other? So for example, here, I'm going to rewrite this as x to the, okay, let me make it smaller. So if you look at this, can you see 2/3 is double the size of 1/3? That's the giveaway. So what I'm going to do is I'm going to rewrite this like this. Now, is that still the same question? Yes, because 2 times 1/3 is 2/3. So what technique do you think I'm going to use to help me again to solve question 8? Okay, it's going to be the K method again, exactly. So you're going to say, let's have a look. Let x to the power of third equal k. And then you have k squared minus k minus 12 is 0. I want you to find what k is for me. I want you to find what k is for me. What is k going to be? Remember, get your pens and papers. You want to be writing and thinking about what comes next. I get that k is equal to 4 and k is equal to 3. Now, I'm still not done because I need to find what x is. But I want you to try and find what x is using this. Isn't it minus 3? Oh, you are quite right. I made a silly mistake there. Thank you for picking that up, Simtanda. And thank you. I see Amy also picked that up. Cheers. So now I have 4 equals x to the power of a third, or minus 3 equals x to the power of a third. But you cannot take a positive number and raise it to a third. Wait, actually, wait. The cube root of 27 minus, can you raise that? You're going to get minus 27. Yes, you can. You can do that. It's a third, so it's fine. You can. We're going to check that now. Okay, what are my answers going to be here? What do we need to do, actually? We covered this in the last lesson. When you have 1/3 on this side and you want to make it x to the 1 and you want to make it x to the 1 here, what do I need to do to both sides? So I'm remembering from the last lesson that I have to raise this side to the power of 3/1, but then I also have to raise this side to the power of 3/1. And over here, I have to raise this to the power of 3/1, and then I have to raise this to the power of 3/1. So what are my answers going to be? Hey, I think the answer here is going to be 64. And over here, it's going to be minus 27. So if you think about it, what's minus 3 times minus 3 times minus 3? It's minus 27. What's 4 times 4 times 4? It's going to be 64. Okay. Give me a thumbs up if you're okay with that. Thumbs down if you're not. Okay. Now, obviously, there are many different variations. If you want to get an A for maths, you have to look at all the different variations of this question. But the K method is a very powerful method that when we talk about complicated exponential equations, you can use. Okay. But for now, I'm going to move on to surds. I will put extra resources for those questions in classroom. But for now, I want to make sure we cover a bit of surds for tonight. So step 1 for tonight, I just want to make sure you guys can all change this from power form into root form. So we'll call this A, B, C, D. And I want you to tell me, what do I get? I'll do the first one. It just becomes square root of 3. Let's see if you can do that. Okay. Okay, so if we look at this, the main thing that we need to remember is that this is going to be like that. So the 4 basically comes outside, the 4th root of 13 cubed. And then over here, it is going to be the 5th root of that. Now over here, the negative actually has to attach to the minus 3. So it has to be like this, in which case we are going to get, sorry, we're going to get this like that. So this is going between power form and root form. Now, the law that we generally talk about in more abstract terms looks like that. And so I'm just checking that you know how to translate that. Are there any questions about that or comments about going between power form and root form? Because when we talk about surds today, the root form is going to be much more common or much more in focus, let's put it that way. Does the exponent go in or out the root? Okay, so Amy, if you think about the exponent, there's the top bit, which stays inside, and then there's the denominator, which goes outside. So the bottom bit is the one that when you go into root form, it goes outside. And then if there's nothing written there, we assume it's a 2. Does that help, Amy? Okay, so what I want to talk about now is what a surd is. Okay, so a surd is just a root of a number that produces an irrational number. So when you put it in your calculator, if you put square root 4, you get 2, which is not irrational. So square root 4 is not a surd. But square root 3 is a surd. Square root 7 is a surd. The cube root of 5 is a surd. Because in your calculator, they make sort of messy answers. They go on forever and they're unpredictable. Whereas a perfect square or perfect cube, it will produce an exact number when you apply the root bracket. So let's just do a quick little check. I want you to say either yes or no for the following A, C, E, G, and I. So yes, it is a surd, or no, it isn't a surd. And I want you to tell me in the chat what you get. What do you get? Okay, so square root 53 is absolutely a surd. Yes, because square root 49 is 7, and square root 64 is 8, so that's a surd. What about C? Is C a surd? Yep, it is. What about E? Because square root 56, if you put in your calculator, it's going to be like 7.5 or 423, blah, blah, blah. So that, yes, it is a surd. Square root 9 is no, it's not a surd. G, yes, it is a surd. Now, what about the cube root of 121? This is a bit of a sneaky one. I'm going to catch some of you. So for I, what is it going to be? Yes or no? Place your bets, people. Place your bets. Okay, it is a surd, and here's why. The square root of 121 is 11, and that would not be a surd. But this is not the square root. This is the cube root. Put it in your calculator now and see if you get a nice, neat number, or if you get a thingy like a horrible looking number. The cube root of 121 will probably be about 4.85, something like that. So it is a surd. All right, so if we think about surds and we can identify them, that's step one. But step two is you need to be able to break them down into pieces. And since surds can, you can change between powers, right? So you could say this law written like this. And that's just converting from surd form into root form. But you can just work with surd laws as a rule as well. So how do they work? Well, if you have the square root of 15, it can be written as square root 5 times square root 3. If I have the square root of 20, I can break that down in a couple of ways, but I'm even going to do it differently to the way the textbook does it. I'm going to say square root 2 times square root 5. And then what is square root 2 times square root 2? Well, that's square root 4 times square root 5. And we know that that would just be 2. So what it allows you to do is almost pull this, break the number inside into two parts. I want you to simplify for me the surd square root of 98. Can you break that down for me? Break down the square root of 98 using the surd law I was just showing you now. Yep. So Amy has suggested that we do that, and in which case this is a nice perfect square. And so we can say that that is 7 root 2. So it simplifies down to that. Now, if you've got that as 7 root 2, that is breaking apart numbers using surd laws when you multiply. But you can also do the same surd law using division, for example. So if you've got the square root of 16 over 25, you can write that as the square root of 16 over the square root of 25. Now, what is that going to do be without a calculator? What's that going to be equivalent to? So the square root of 16 is 4, and the square root of 25 is 5. So you just need to know how to work with these laws for surds. And the best way to do that is just to kind of get used to using them. So I'm going to ask you to do question 4. So question 4 looks like that. If I had to rewrite it in the way that I prefer, it would be written like this. And we have to simplify this using the laws of surds. And I'm going to wait for people to make comments around where they think their first stop should be. Where do you think our first stop should be? The top, absolutely. What would you break 48 into, Stephen? What do you think we should do? It seems like perfect squares are always a good thing to deal with, huh? So I was thinking I could do that, maybe. I don't know if you agree with me, but maybe not a bad way to start. And then what about the 27? What could I do with the 27? Oh, yeah, Amy, you're quite right. You spotted that square there. So you could say that. Now, what I could also do is, what do I need to do with the square root 75? So we've done that one. Done that one. Let's use a different color. Let's use green. So we have, I think, 25. So square root 3 times square root 25. Now, what is my final answer going to be? Remember, we're not allowed to use calculators in this section. We have to work through this. So I'll give you a moment or two to find an answer for this. I think. What's my final answer going to be? So I've got 4 of something, and I've got 3 of that same something. I must have 7 root 3. And then over here, I've got 5 root 3. So what does that final answer then need to be? Yeah, you just cancel that out and you get 7 over 5. Perfect. Okay. Everyone, we're halfway through the lesson. It's time to turn on your cameras. I want you to join me in standing up. You know you want to. You know it's been a long day and that your brain is begging you, please take me out to play. So I want you to join me. I want to turn your cameras on. Take some nice deep breaths. Breathe in. Hold it. Okay. Another nice deep breath. I want to see those cameras on, guys. I want to see you. Join me in my exercise studio. One more breath. And hold. Okay, and then I want you to shake out your arms. I want you to get blood flow. I want your body to relax. Until you get nice and loose, your brain is not going to be happy. Shake out your legs. Okay, then I want you to twist a little bit, so arms out. Just very lightly to start with. And then as we relax, you'll go further. Doesn't that feel so good? Oh my goodness, this feels good. You are missing out if you're sitting on a couch or a table. Okay, let's roll your shoulders. To roll them back. In case you've been hunching your shoulders and they're all tight, roll them forward. Oh, that feels so good. And then some small circles. Change direction with your small circles. And then one more shake of the arms, shake of the legs, and your body's going, oh, thank you so much. But before your body gets too excited, let's do some jumping jacks to get some blood flow. So we're going to do jumping jacks like this. And make sure you are clear. There's nothing to whack with your arms. And we start in 3, 2, 1. Let's go. 2, 3, 4, 5, 6, 7, 8, 9, 10. 5 more. 11, 12, 13, 14, 15. And you have earned a break. Well done. You earned a break. And I must be honest, my heart rate is also pumping. But that's the point, isn't it? And then let's do a little brain break puzzle. I have got some Angry Birds for you guys today. So tell me how much these Angry Birds add up to. Cool. I know. I can feel my heart rate, but it's somehow my brain is happy that I've done it. And we're gonna get another 20 minutes of good quality concentration out of our brains now. So Amy, you see your brain's working already. 4 times 4 is 16. So a green Angry Bird is 4. Atlekhang, you're in there as well. Well done. Now, what is the next one going to be? It's a bit of a tricky one because it's got to be something divided by something is 3. And then that same something plus 4 minus that. Yeah, like we need to somehow work out what the green and the orange bird are. Okay. I'll give you a hint because we're a bit short on time. I'll give you a hint. Try 9 for this. Try 9 for the green Angry Bird or the light green. See if that helps. So if this is 9, what does the red bird have to be? I think it has to be 3. Yes, it has to be 3. So what are 3 Angry Birds equal to? What are 3 Angry Birds? 4 plus 9, and it's plus. There's no fancy BODMAS. So the final answer, indeed, Stephen, is 16. Okay. Are you guys ready for another shorter session now? Does your brain feel a bit happier now that we've taken care of it? Tell me how you're feeling. All right. Let's do these 3. I want you to do A, B, and C using the laws of surds that we've seen so far. And just pop your answer in the chat when you're done. First one is kind of easy here. If I square root something, it's the same as a power of a half. And if there's a 2 there already, the answer would just be 4. Yeah, piece of cake. Now, what about B and C? I do notice there's a 3 and a 3 here. That makes me think of this type of thing. So using the laws of surds for this, I think this will just be the cube root of 8. And so the answer will be 2. Yep. And then lots of you guys have got that. So it's 2. Yeah. Let's do C. What is square root 12 times square root 24 times over square root 8? There's a couple of ways we could do this, actually. But what's the quickest way, I guess, is the main question. How would you, what thoughts? Yeah. So the one way of doing it says go square root 4 times square root 3 times square root 6 times square root 4 over square root 2 times square root 4. But the other way that I was thinking of is if I could get rid of, if I could do this, why is the blue way so sneaky clever? Who can tell me why the blue way is sneaky clever? I want to hear some voices. Put your hands up. I want to, who thinks they know why I'm being sneaky clever by doing it like the blue way? It's still the same thing, but what's lovely, yes, Stephen, let's go to you. What do you think is quicker about the blue way? Can you hear me, Stephen? I think maybe your audio is not working, but okay. So,
can you hear me?
oh, there we go. Cool.
Yeah, so what I
Yeah.
was saying is basically what I did, I'd say 12 times by 24. Then it gave me 288 over the square. And then I divided it by 8.
Aha. Okay, so that's what
Yeah,
I was
that's
trying to,
what, so
I
I
was
didn't.
thinking like this. Like if you get the 8 there, they can disappear. And then if you think
Yeah.
about it, from there, then you've got the square root of 36. And then what would you get for that?
Which is 6.
Yeah.
6.
You still get there using the other ways. There's nothing wrong with that. So I'll just show you that you can get there both ways. Like if you do it the other way, you have to cancel that out. And then you would have, what would you have? You would have square root 4 times square root 3 times square root 3 times square root 2 over square root 2, and that would cancel out. And then you would have the square root of 4 is 2, and then that's going to be 3, and so you're going to get 6, which is the same answer. So both answers work. It's just a matter of, yeah, what approach you take. Thanks, Stephen.
Okay.
All right, let's keep practicing. I want you to do for me C, I want you to simplify C, and I want you to simplify D. Can you simplify C and can you simplify D? And you pop your answer in the chat. So that's how I would start for C. What is my final answer going to be for C? And so then this is going to cancel and we get 2. So the answer for C is going to be equal. That whole thing is actually equal to 2. Let's see what we can do with D. What can we do with D? It doesn't seem obvious for me where to start. So I was just thinking, start with that. And I guess on this end, I could start with that. What do you guys get for D? So I guess the 5 is making me want to do this. So like square root 12 times square root 5. Now I know square root 7 times square root 7 is useful. I know square root 5 times square root 5 is useful. So let's just make sure I've got rid of those. And then I think I can write this as square root 3 times square root 4. That's the 12. This would be 7. That would be 5. That would be 3. And that would be 2. So what is my final answer going to be? Seven times 5 is 35. Times 3 is 105. Times 2 should be 210. Give me a thumbs up if you're following okay. Give me a thumbs down if you are feeling a bit lost. Give me a face in the middle if you're in the middle. Okay, did I lose you there, Amy? No problem. We're going to slow down then, just so that we make sure we let's do another one like that. So let's do this one. Can you simplify the following expression? This looks like something out of the old test. See if you can do it. And if you have a question, you can just raise your hand and we can have a little discussion. You guys are doing well, though. We're really getting into surds today. What's my answer going to be for this one? Remember, no calculators, huh? So I get 5 root 3 over 5 root 3, which the 5s cancel, the root 3s cancel, and so I get left with a 1. Yes, Lorato, nicely done. Yeah, so you can see it does get easier. So let's choose something really tasty to try and make things a bit exciting for you. Okay. Let us, what looks interesting here? Let's do this one. Let's do 3.1. It's a bit of a, let's just see how we handle 3.1. It's not tricky, but some of you might find that confusing based on what we just did. So let's do 3.1. What do we get for that? So this is 1 cube root 5. That's 9 cube root 5. That's 4 cube root 5. So what is 1 plus 9 minus 4 going to be equal to? So forget about, remember, this is the same thing. It's the cube root of 5. But the coefficient is important. So what's my final answer going to be? I've got one of those, 9, and then I take away 4. I end up getting 6, but it's not just 6 of anything. It's going to be 6 cube roots of 5. Okay, can you do 3.2 for me now? Try and do 3.2. So that wasn't hard. You just had to understand, like, the fact that the like term was the cube root of 5. See if you can do 3.2. I wonder if I should do that. Yeah, plus 6. Now, what do we have? So 12, or maybe I should actually, you know what, instead of going to that, let's leave it with the 9s in it, and then it's easier to put them together. So I get 12, and then I can go 3 root 9 times root 5. I don't know if this is actually even the best way to do it, but I'm kind of artificially making sure there's all of these here. Let's see. So what would this be? Well, that would just be 36 because it's, and then this would be minus 9 root 5 because you get that. Now what would happen here? You'd get plus 18 root 8. But then it's actually not a very nice one because root 8 can be written as square root 4 times square root 2. And the square root of 4 is 2. So that's going to be 36 minus 9 root 5 plus 36 times root 2. And have I missed something? No, because the square root of 5 is a prime number. Square root of 2 is a prime number. That's a messy one. So everyone, I don't know, you can't really go much further because this 36 root 2, that's 36 by itself. I feel like maybe that was a mistake in the question there. So let's do one more for tonight, then we call it a night for tonight. So we are going to do 3.5 to end tonight. Let's bring it home strong. You can do it. You can do it. What is the final answer for 3.5? So 3.2, don't worry if you're feeling a bit confused by that. I think the question was set up a bit faulty there. So apologies if you're feeling a bit confused there, but let's do the purple one to finish the day. And what would I do for 80? Who has some good ideas for 80? What should we break 80 down to? I know square root 98 we dealt with earlier. That was just that one. So that's fine. That's fine. What about 80? What should we do with that? Oh, yes, Amy, I like it. Yes, yes, yes. Okay, so 16 times 5. So we go square root 16 times square root 5. So then we're going to get 3 root 2 minus 4 root 5 plus 7 root 2. Now, we can only put these ones together because they have the like term of root 2. And so those two together will give us 10 root 2. And here we will have minus 4 root 5. We can't really break these down any further than the prime numbers. And so that is it. You would just get down to that point. So it's a little bit like exponents where you use the prime bases. Here you're using the prime surds to help you.